So almost flying blind. So overnight, you've gone from full visibility, you've got asset suite down to a small nano window of visibility of what your assets are doing and performing. Having said that, in some of the larger companies that would have invested in advanced sensor technology, intelligent electronic devices on the network, smart grids, etc., they potentially would have an advantage because they would still get the data coming in, but they wouldn't be able to react. So in terms of reacting to data that's indicating early asset failures out in the field, they would just have to watch the assets fail rather than actually be able to do anything about it. I'm based in the UK, as you probably guessed from the accent. So this slide is very UK centric, but it just tells the story of what happened in the UK. So between the 29th of January this year, when the first 2 cases of COVID were recorded in the UK, between that day and the 23rd of March, when the whole country went into lockdown. So by that lockdown, everyone was confined to their homes. So you weren't allowed out, or over a period of time, we were allowed out of our homes for exercise, walking the dog, etc. But in terms of undertaking work, everybody was, where they could, was working at home. On the bottom right-hand side of the slide, you'll see a few photographs of London. These were taken during peak time during the day, so peak tourist time. The London Underground, the train stations and everything were just deserted, which is just unheard of. So it was, an extreme, unprecedented event. And then, obviously, with the global pandemic, is having financial impacts. So on the far left-hand side, you're looking at the financial impact. So you've got the FTSE and the Dow Jones just plummeting off the scale there as a result of COVID around the March period again. Investors are going to have second thoughts about investing in companies that are asset management companies, for example. So everyone's going to be nervous about how their assets are going to be maintained, how the companies are going to survive. The middle graph is millions of workers furloughed. Now, in the UK, there's a job retention scheme called furlough, which I think similar schemes occur in different countries, but not every country. So it basically means so people still retain their jobs for a period of time if they can't work from home. So a lot of those people in the asset management sector would be the site inspectors. So the people that go out on site, inspect the assets, maintain the assets. So they should have been protected by this scheme. And the right hand side is looking at flights, and as you can see, the flights in 2020 just bottomed off. It's the bottom line, and it's the red line at the bottom of the graph. So you can see, comparing that with other years, flights have hit rock bottom. So you've got an interesting aspect of asset management there, because you would have had these large aircraft flying around the world. I don't know the stats for the percentage of time they're actually airborne, but it's pretty high, because on those expensive assets, you need to maintain them operational and keep them flying to bring in the profits for the company, because they are expensive assets. Now you've got them sitting on the ground. You've got them semi-mothballed, and the same thing's happening in shipping as well with the cruise liners. You've got to mothball these assets, but keep them turning over, which I understand is incredibly difficult in shipping in particular, because you have 2 different types of mothballing. You have the dry preservation and wet preservation. So dry preservation is where you take them out of the water, shut everything down, but then you have issues with when you have to start them up again. So you have to start the systems up from scratch, and cruise ships are designed to be running for, again, like aircraft, for a high percentage of the time. So you don't like being shut down completely and started up again. And the same thing with aircraft as well. Um, and these are some of the reactions I've had from some of the people I've been talking to, some clients and some people in Black Veatch. So some people, I mean, not everyone will agree with this, what this slide is saying, but some people, are reporting that, working from home is giving them a better work-life balance. I think that's very much depending on individuals' situations. It's okay. I mean, I'm quite lucky. I've got a dedicated office in my house, so I can lock myself away from the rest of the family for the whole day and not be disturbed. But other people I talk to are in shared dwellings, so shared flats in the central London. So they might be sharing houses with 3, 4 other professionals that are all trying to use the Wi-Fi at the same time, all trying to work. I think that's going to be a lot more stressful. Other people are reporting that working from home gives them greater flexibility of hours. So they're not expected to work the 9 to 5. They can integrate their childcare or caring for relatives within that working day and catch up with hours in the evening. And I think one of the figures that's quite staggering is in the middle in the UK. This is, so apologies, it's a bit UK centric again, but 49.2% of adults were working from home in April 2020. And the same stat in the UK from the year before, I think, was about half that figure or less than half that figure. So that just shows in a matter of weeks, we've gone from an office-based environment to a home-based working environment. And again, so the more negative angles of the situation we're in would come from people who work more on site, who do the asset inspections and maintenance again, as I said, so that will interrupt their work more severely than if you work in an office. So there's going to be feelings of people are going to feel isolated at home. There's going to be a lack of culture, working communities, etc. So there's going to be a real mixture. Some people like working at home, some people don't. Some people can work at home, some people can't. So there's a real mixture of issues there. And again, not dwelling on this too much, but again, as people's mental well-being. So what people do outside of work. So social gatherings in the UK and across the globe have been restricted. Sporting events have been restricted. So if you've worked at home for a whole week on busy, you can't unwind at the weekends by going to watch some football, some cricket, or whatever. Religious events have been, religious festivals have been impacted. There's street closures. So in some countries they would have street parties for various events that they haven't been able to do that, and it's just the psychological impact of probably not seeing people. I know I found it very odd at the beginning. Being a consultant that visits client organizations every day and having that people interaction face to face, going from that overnight to having Zoom or Teams calls is quite different. And it's hard to judge how people are taking on board what you're saying. It's you need to have that active listening involvement going on, which is quite hard to do over a camera, or maybe it's an age thing. I just find it difficult. So I think we've covered a lot of these, but I'll just go through them quickly again. So again, COVID-19 impact on asset management would cover everything: people, processes, systems. So operational assets, operational people, and it's the balance between risk and uncertainty and getting your investments right and making sure your assets are maintained to a sufficient quality that they maintain operational to supply clean water, electricity to the public. And there's a diagram there called digital twins and data, which I'll come on to in a moment, because there was an opportunity for this situation here to actually kickstart the digital revolution again with data and digital twins, which I'll talk about in a bit later. So just that was the section on people. So I think that's a very important aspect. It's an important aspect of asset management, and it's also an important aspect of what we're going through at the moment in terms of COVID-19. I'll now move on to the breadth of asset management, so we all understand what we mean by the term asset management, for example. So asset management, there's various definitions, but I've just chosen these from ISO 55000. So it's looking at the coordinated activity of an organization to realize value from its assets. So that means you create an asset. Assets are valuable things, and they need to be cared for, maintained to optimize their performance and to maximize the life extension of those assets. So you get the maximum return on your investment. And a lot of the people that I'm talking to as a consultant, I talk to company owners, and that's what they're looking for. They invest in their assets. They want to see value from those assets, and they want to extend the life of those assets for as long as possible. An asset can be anything. An asset can be people. An asset can be a piece of mechanical kit, a civil asset, anything that has the potential to add value to an organization. And this is one of my bugbears, so I just wanted to cover it. But there's a difference between asset management and management of assets, or managing assets. So asset management covers what I've been talking about so far. It covers aspects of an organization in terms of its stewardship of its assets, its people, its processes, its procedures, its systems, and its data. So it covers a wide range. It's not just looking at engineering. It's not just looking at training. It's everything. It covers a wide range. It covers IT. It's operational IT. So the sensors in the field are relaying the information you want when you need it. That all covers asset management. But it's also, in terms of training, it's developing a company culture. It's developing a belief culture, can-do culture, and a culture of positive intent. So when you've got asset management working well, they're the types of human behaviors you'd expect to see. And on the other side, so managing assets, or it's a subset of asset management, which is just basically focused on the asset. So, and the asset being a mechanical asset, a civil asset. So an engineering asset, in other words. So it's an asset that does something in the field. So it could be a pump, it could be a pipe, it could be anything. And it's how you optimize and get the life extension of that asset. So it doesn't include the human impact or the IT impact of that. So it's just purely looking at maximizing the life extension of the asset and getting the best performance of that asset. And again, this is just emphasizing the fact of what I've just gone through, so I wouldn't spend too long on this, but there are many different assets. Humans are an asset. Information and data are assets as well. And you have financial assets. So whole life cost models is understanding the whole life cost of that asset. That's important to investors. The intangible assets, now that's an interesting one because companies view that differently. So an intangible asset is reputation, company reputation. So, but it all links in through to physical asset management. So reputational management could be impacted by the ability of your company to supply a service to customers. So say for a water company, it could be the water company's ability to supply clean drinking water to customers. If it has frequent interruptions to supply, then the reputation will start to be damaged. That reputational damage may mean investors are less likely to invest in those companies moving forward. So from that pump failure or that burst pipe, or those pipes that keep bursting, from that operational side, it goes right back to the boardroom and the investors, which is when we do the asset management maturity assessments. This is one of the things where we're trying to get across to people, is the fact that every action in an operational environment will have an impact associated with it in the boardroom. So it's important to get that line of sight. I'll mention line of sight in a bit. We talked about those. I'm going to talk about these in more detail. I'm just conscious of time. So, like I say, asset management value. you get value from investors, customers value. So do customers value the service they're getting from service providers? Regulators. So regulators will assess company performance on comparable metrics. So again, if you're doing what got a good reputation with your customers, good reputation with your regulators, you've got an engaged employee force that understands the value they add to the organization. You're engaging local communities. So you're not the big sort of corporate company enforcing its will, but you're part of that community. You're employing local people, and you're engaged with corporate social responsibilities. So you're looking at your CO2 emissions. You're trying to be a clean company, a valued company, and part of the community. That's what we mean by value in asset management. And that, as I said, that can be driven by management of assets. So the performance of your assets, your unplanned interruptions of assets that may damage your reputation with customers and regulators. So line of sight is basically trying to sum up everything I've just said there. So it's looking at the line of sight from some of the work execution right back to your corporate objectives. So corporate objectives will be defined by the board. Asset management policies and asset management objectives should link through to your corporate objectives. So it's just a way of how you're going to achieve your corporate objectives, and that filters all the way down through the different structures within the organization and across the structures as well. So it's not just looking at asset management engineering, it's looking at IT, HR. If we need to develop a behavior, so have people got the right training, for example, to operate the assets in a way that they're going to be asked to operate the assets in the future? So I'll touch on digital twins in a moment, but moving towards a more digitally enabled environment, the workforce of the future is going to need that skill set of understanding data quality and data management, and how that will inform investment decisions and maintenance decisions, rather than basing it more on experience of past asset failures, for example. If you get your data and your digital twin right, you can have a more informed, data-driven asset management view of the world, and that's going to be discussed during the next webinar in more detail. And this is just looking at line of sight, but in a different axis. So this is looking at it through the life cycle of the asset. So from concept, design, build, commissioning, and it's just highlighting the things that you need to consider. So you need to consider operational risks, maintenance risks. You could change your maintenance strategy and operations to maintain the asset less frequently. But if you don't do the assessment properly, you're going to potentially increase your maintenance risk, so your risks of failure. If you have an asset failure, that might lead to a compliance risk. So if you've got water quality standards that you need to comply to when the assets are running 100% efficiently, that's fine. But when you have any interruption to supply or asset breakdown, that might affect that ability for the organization to supply that water to sufficient quality. So you have a compliance breakdown. You're looking at growth opportunities. So there's opportunities to grow the organization through your assets, but there's also growth can be a bad thing as well, because you're looking at catchment growth. So you're looking at within catchments of I say water companies or power companies, you might have large developments planned. So you might need to look ahead, plan forward about how those growth developments, large developments, are going to impact your assets. So a lot of the time, there'll be utility companies, particularly in the UK, are reluctant to upsize assets. They'd rather sweat what's known as sweating the asset as much as they can before they need to replace it. Now, there's a fine line between sweating the asset and having a catastrophic asset failure. So there's always a fine line where the engineers and accountants are almost sort of at loggerheads knocking together about when replacement needs to happen. And it's the same in asset management, and this is what we're highlighting, is the fact that asset management is pulling everything together. And leadership. So having visible leaders, I mean, it's one of the elements that when you measure the ISO 55000 accreditation, you'll be assessed on leadership. So are the senior managers, directors of the organization demonstrating the right culture, demonstrating the right behaviors to influence the workforce, to have that can-do, positive intent, belief culture that really sort of, once you have that within the leaders, it spreads across the company, and you see companies, their performance will change. It doesn't happen overnight. It takes 2-3 years sometimes, but it really is. So it's the shadow of the leader. It's been said to me so many times in so many training sessions about the shadow of the leader and the influence that leaders have over organizations, but it's so true, and it needs and it is addressed within asset management, because it's assessed right from the top level management right through to the shop floor and the operators. So this slide is just making sure that asset management, there's key characteristics. It's holistic, it's systematic, it's risk-based, it's optimizing, it's sustainable, and it's integrated. Just those words there, sum up what asset management is all about in an ideal world, and that's what organizations should be looking for to optimize and really develop a first-class asset management sort of organization. And to do that, you're always balancing cost, risk, and performance. So cost, everyone should be familiar with, how much things cost. And there's another slide in a moment which I'll explain a bit more about that. But risk, what is the risk of failure? What is the consequence of failure? What's the probability of the asset failing? What's the consequence of that asset failing? How do you recover from the asset failure? And that all drives your overall company performance, which again goes back to your reputation with customers, with regulators as well. So again, this is cost, risk, and performance is a key part of asset management, and we discuss it so many times in our work. This is an interesting diagram. So this is supposed to look at what organizations believe costs are. So the top half, it's initial costs. So the initial costs to create and acquire an asset, I think from my experience, and again, feel free to disagree, most companies are pretty good at that. What they're not so good at is looking at the future costs. So what are the actual costs of maintaining that asset, obtaining spares, decommissioning the asset at the end of its life, how you decommission it in a socially responsible manner? That often gets forgotten about. Environmental costs. So not only just with decommissioning, but if you have an asset failure, if you have an oil-filled piece of switchgear, electricity switchgear or transformer, there's environmental costs with the oil spillage and the cleanup. Energy consumption. You can get very energy efficient assets now, as you can, cars. You can get battery operated cars. You can get energy efficient assets. So again, asset management is all about influencing how costs are assessed and viewed over the lifetime of the asset. So it's looking at the whole life costs. And there are some ratios there which a colleague of mine pulled together, which we believe are, from our experience, represent what companies do in terms of the initial costs, which are well defined, and the future costs, which are less well defined. So in terms of people doing asset management, there's many different types of people do asset management. So the operator does asset management. So they provide services to customers by operating the assets. But they need the assets to operate in a reliable manner. They need to know if they turn a valve, what's going to happen. Modelers and planners, they assess needs to meet business objectives. So again, they need to know what's around the corner, what's on the horizon, what's going to change in the future to enable the asset infrastructure to operate effectively. Designers, all part of asset management. need to know what they need to know the performance requirements of the assets they're going to design. Supply chain and finance. Again, touched on this previously, but again, they need early visibility of what the designer is going to design, so they can start securing assets at a favourable rate. They need lead times to be understood. Solution and delivery. You need to know what you're going to build up front and in good time. You need to sort out your land entry, etc. So all that is asset management, and all that is done by people. Again, optimal asset management is about holistic integration. So again, I've talked through some of this before, so I won't spend too much time, but optimal asset management includes HR, human resources, personnel. So you need people to have the right skills to do the right job to maintain the assets to maintain operational performance. Strategy and regulation. A lot of utility companies that I deal with in the UK and Europe are governed by regulators. So you need to understand what the regulators' requirements are now, but also in the future. How are their requirements going to change? How's that going to change what assets you're going to choose to put in the ground in your infrastructure, and how you're going to manage and maintain those assets? Engineering and maintenance, essential for the management of assets. Customer service, as we spoke about before, they're going to need to know what's happening. So if an emergency does happen in the field, so an asset fails, people go without water, they're going to need to understand the repair times, the response times, and a lot of that will be down to the assets that are involved in that asset failure. Finance, planning and performance, risk management. We've talked about cost, risk, and performance, but emphasizing the fact again: supply chain, IT, and operations. So the benefits, I've talked about some of these, but HR, incentivized workforce, the objectives are aligned. So people's performance objectives in their annual reviews are aligned to the requirements of the organization. So they know the benefit they're adding to that organization. So it's all seamless. Improved forward planning for engineering and maintenance. They know how to reduce the whole life costs. They know the common failure modes of the assets. They've undertaken FAMICA, which is failure mode effect criticality analysis of the assets. So they understand what and when it's going to fail. They've got some probability of failure models, and they've got consequence of failure models. Strategy and regulation are kept informed of what's going on, and also it's a proactive part of that. So it's talking to them up front to understand what changes are coming ahead, so we can react to that and invest ahead of those changes, so we're not caught on the back foot. Customer service, faster responses to issues, improved service provision, reduced complaints, all adds to your intangible assets, which is your reputation. Finance, goes without saying, the finance director needs to know how much he's going to need to spend in the future to maintain profit margins for the investors. Planning and performance, risk management. I'm going to whiz through these. We've talked about them before. I want to talk about digital twins. So supply chain, vendor rationalization. Who supplies the best assets, and what commercial arrangements can be made to reduce the cost of those assets over the whole life. So sometimes the cheapest asset isn't the cheapest assets to buy, it's the cheapest assets over its whole life cost, which again, sometimes when you're talking to procurement professionals, that you have to remind them about that. And IT, so operational IT, sensors, intelligent electronic devices or IEDs, essential in the new world of asset management when you start looking at digital twins, which we're talking about very soon. And operations, reducing operational costs, increasing productivity, it's all surrounding around how to optimize asset management. This is a framework for asset management. This is taken out of the asset management anatomy. And it's just the standard model that you would build an asset management directorate on. These are So there's 6 groups and 39 subsets. And when you're doing the IM diploma, you go through all of these individual subjects. And also when you're doing the ISO 55000 accreditation, you're looking at each of these aspects in turn. So as you can see, asset management is a very involved discipline. So as you can see, organisation and people, group 5 there is a whole set on its own that you assess a company on. And these are some standard literature if you want some further reading. So it's the ISO 55000, the asset management landscape, all really excellent literature to read if you want to know more about asset management. If you're a bit of a newcomer to the discipline, then I would recommend the Asset Management and Anatomy. Is a great introduction to asset management if you are fairly new to the discipline. So asset management, COVID-19, so data. So as I mentioned before, companies that invested heavily in sensors, intelligent electronic devices may have benefited from that as a result of not being able to send operators out to site. And one of the enablers of that digital technology is data. So when you're looking at data, you need to assess data quality. So one way of doing that is looking at what we call the track score. And I'm going to explain it back to front. So the C in track is completeness. So is your data complete? So is there a value in the spreadsheet, for example? Accuracy is A. So is the value compliant with data rules that you would expect? So the accuracy of data. So if it's a 16-digit alphanumeric code that has to be entered into the box, does it match that requirement? Reliability. So reliability is looking at, is the data captured manually, subjectively, or is it captured by an electronic device that is within calibration, which would hopefully be more reliable. And timeliness looks at basically how old the data is. So if you expect 15-second data from electronic devices coming back, is it within those timescales? Is it a year old, for example? Another way of doing data quality is looking at a data assurance guide. So it's looking at the standard way of auditing data as well. So this is impact, probability, and control. It's a standard audit model. So you're looking at the impact of customers, the financial impact, and competition, for example. We're looking at the probability of errors occurring in your data. So you're looking at completeness, you're looking at the complexity and maturity of the reporting rules, the extent of the manual intervention. So ideally, your data should be captured, seamlessly go through a series of systems to the end user, whereas in reality, in some organizations, there's an extent of manual intervention between those systems. So you can sometimes get errors that slip in through human sort of errors. And then you look at the control activities. So where you've got those human interventions within your data flow, you're looking at what control activities. So so someone changes the data for a legitimate reason, but is a supervisor managing that process? Who's looking at it? Is there evidence of historical errors? And this is looking at how the CART and DAG process, which we just talked about, coexist really. So the data assurance guides, so impact, probability, and controls is really a top-down approach. It's what directors, investors would look at, and the track element or the CART element is what operators and asset management teams would look at from a bottom-up perspective. So you put the two together, you got a top-down and bottom-up approach, which works really well. We use this a lot with our clients across the Europe. We talked about this quite a bit, so I won't go for that. So final part I want to talk about is digital twins. This is a really exciting part and this is one of the opportunities of coming out of lockdown, which may explode. So digital twins are for those of you who are not familiar with it, it's a realistic digital representation of a physical asset or a physical network of assets, and it's built up by data inputs that are available on those assets. So you do need good data quality to create a good digital twin. So why have one? Well, you'd have one because once you've got a digital representation of a say a complex asset like a nuclear power station, for argument's sake, you can undertake operational tests on the digital twin without having to take any risks with the actual assets in the field. So you can do this on a computer at your desk and just change, if you want to change maintenance strategies. So rather than inspecting the assets once every 10 years, you want to roll it back to 15. So you'll see what happens. You'll see what assets might fail. You'll see how they fail. You'll see how one asset failure can have a knock-on effect and make another asset fail further down the network. So you'll be able to do all of that. You'll also be able to train your operators. So if you want to run scenarios, you could run emergency scenarios on reactors or any type of asset that you want, and you could train your staff to react to those emergencies on the digital twin, not having to risk real assets failing out in the field by running a scenario, which some companies do. They take assets offline and run a piece of plant to almost failure, where an operator has to step in, which if the operator doesn't get it right, the piece of kit sort of catastrophically fails. Well, on here, they can do it electronically without that risk of failure in the field. One thing I would say in the UK, there's a Centre for Digital Britain are looking at building a national digital twin. So this is a long way off, but it's one of the aspects of the digital twin science that is really taking interest. And to do that, it's developed a set of principles called the Gemini principles. So to build a digital twin for the national good, it has to have value creation. They have nine principles in the Gemini principles, and they have to tick off each of these principles before they actually build a digital twin for national critical national infrastructure. And this is all work in progress. So this is all being undertaken as we speak. But again, Gemini Principles is a good read if you want to understand more about digital twins and data requirements that go into them. Again, digital twins in the water sector. Yeah, I think we've talked about that before, so we'll just go over that one. So support via the digital twin. So why have one again? So the site manager, I need to run the site to cost. So you need to have that informed decision making about, if you change a setting, how is that going to change my chemical and resourcing needs? And you can run those scenarios on the twin. The operator, how am I going to conduct maintenance? Quite often when I visit sites, the operator has to maintain assets that aren't very accessible. Whereas digital twin, you would realize that asset wasn't accessible or easy to maintain before it was actually installed through the use of the model. So there's many different benefits of a digital twin. Go over that one. And this is one of my final slides, but after digital twin, you got artificial intelligence and autonomous control. So that's the next thing that will be coming in volume, I believe. So this will be discussed more at the next webinar in a couple of weeks' time by my colleague Chris Still. But this is just to give you a flavour of what type of things will be discussed. So we'll be talking about edge analytics, the user experience you can get through AI, how that's going to be coming on board over the next 20, 50 years, and the different uses. So it can be used for strategic and tactical asset management, but also transactional. I think people are more familiar with the transactional sort of data and reporting type of use of AI, but how you can start planning your network, how you can start predicting asset performance issues using AI. It's all good, exciting stuff, and sitting behind that is data science, which Chris will talk about at the next webinar. But before you go interstellar, there's things you need to remember before you go off and build a digital twin. You need to understand what the critical decisions are you're trying to resolve and what data sets you need. Keep it simple. So many people I talk to try and build a massive digital twin where actually if you start off small and build out, it's a much better way of doing it, because you actually build your own knowledge and understanding of how digital twins work by doing that. If you just go big, you'll miss out on so much learning. Get people involved, find champions. You tend to find people are really interested in data, will want to get involved in digital twins, and conversely, you'll find people that, I've done it the same way for the last 30 years. A digital twin, what benefits are going to give me? So you'll tend to find people fall in different camps on this, and limit subjectivity. So keep it data focused. So as soon as you inject a bit of subjectivity into a digital twin, you're moving it away from data. So you're moving it away from historical events that you can calibrate the model to. So it's harder to forecast what the future reality might be. So final slide to summarize. I think the impact of COVID-19, it's affected everyone very badly across the globe, but there are potentially some plus sides. One of them is it could kickstart the digital revolution in terms of asset management and digital twins. Data is becoming increasingly important. Springboard for data-driven asset management, and it's an opportunity for wider interventions, in the integration rather between utility companies and environmental organisation, public bodies, just to embrace the whole end-to-end collaborative asset management ethos. And the last thing, as I said, it was one of my bugbears. Asset management is wider than just managing assets. So, that's me. Any questions?
Fantastic. Thanks a lot, Ian. I think that was absolutely brilliant presentation. So I really loved the track concept for data quality, and which is obviously a big question around asset management, because
Mm-hmm.
if you're actually making decisions on data received and data interpretation, obviously the quality of data really matters a lot. A very
Yeah.
common problem I keep facing, and the challenge that I keep facing when I interact with clients invariably, is when we talk about all of this buildup of data. A common problem that I see, okay, so basically, are you expecting me to have thousands of data collection devices established, network and telemetry system to collect that information, and then subsequently dashboard, which means that you're actually asking me to put in loads of money into something that I've been traditionally doing anyways. Maybe in parts, may not be as brilliantly as I would, but then
Mm-hmm.
what is the common delta that you would expect in case you actually have all of these systems effectively set up, and how much benefit it really awards to people who do asset management in a classical fashion, as you described over here. So is there some kind of historical record that, okay, people who haven't actually used asset management system to track the asset performance,
Mm-hmm.
vis-a-vis who have now done that, do you see a significant, what delta do people really see in terms of the actual value you are able to get out of implementing such complex systems?
Yeah, it's an interesting point, and the value, the value you get out of asset management depends on what you put in, and it's also got to be sized appropriately for the size of the company. So one company I work for is very small. It's a small water-only company in the UK, employs 500 people. Their asset management practices, procedures work well for them. So they rely heavily on locally based resources, locally based employees. So it's different generations of the same family have worked for that company for many years. So when the father hangs up his tools, the son or the daughter takes over his job. So that learning stays within the business. Whereas you look at the larger companies that I work for, where you have a higher turnover of staff, you don't have that community focus. You have to have that handover of data and models to get that understanding of how the assets and the systems work. And the other thing I would say is when I'm doing asset management maturity assessments and start looking at data, I quite often quiz organizations about why they're collecting so much data. And quite often, one of the first tasks I undertake is to do a data rationalization exercise. So rather than asking companies to collect more data, I've actually started off by saying you don't need to collect this anymore because you're not using it, or it's not adding any value. And then what we do is do an exercise where, if you're looking at assets, you might do a FMECA, failure mode effect criticality analysis, which will tell you the common failure modes. And then you start talking to operators that will tell you what are the leading factors and what are the lagging factors of those failures. So how do you know what's the early warning of those failures coming? And that'll tell you the data that you need to collect. And after you've done that for a while, you'll start to see your reactive maintenance spend go down because of you'll be proactively investing before the assets fail, which has got to be cheaper than letting them fail. So it varies depending on what company and
Right.
the sizes of the companies. It's very hard to put an exact figure on it.
Sure, sure, absolutely. So I've got a question from Karthik Sai. He says he's asking, in oil and gas, we are developing projects based on smart plant modeling, and all the components are with attributes. So this model is then used to develop the project. How do you see this developing into a digital twin? So essentially, the typical smart plant applications used, which are predominantly 3D clash detection based models. I mean, the question is, can these be converted into digital twins?
I mean, yeah. So yeah, I must admit, I'm not too familiar with the oil and gas industry, but I'll try and relate it back to something I'm more familiar with. So in water, you've got a hydraulic model. So a hydraulic model will sit in one IT system. Um, you'll also have a structural failure model of the pipes and the M&E equipment. So the pipes will be in a different model and the M&E equipment will be in a different model. So you've got three models. So if you combine those three models together into one platform, then you've got the combination of a digital twin. But you could argue that each of those three models is a digital twin because it is a digital representation of a physical asset. So the hydraulic model is, the pipe structural integrity model is, and the M&E model is. But if you combine them together, this is where you'll get, so if your pump starts to fail, your pump failure potentially might have a consequential failure on the pipe network. Or if your hydraulic supply, if you need to get more water into supply, you're going to be increasing the pressure which the pump is capable of, but the pipeline may not be. So you identify issues like that. You identify the weak point. So it could be, a weak section of pipe that's burst frequently. You could be identifying, you're going to have to reroute water around a different route that you wouldn't normally do, and the pressure rating of those pipes, won't manage. So it's having a common IT platform to enable you to combine those three models, asset models together.
Right. Okay. Great. Thanks, Ian. I hope that sort of answers this question. There's another interesting question from Sudeep Saha, and Okay. He's asking, if I'm not wrong, asset management also involves changing inefficient procedures or processes at an operational level. How do you address the risks of operational change management using asset management philosophy?
Right, operational, any sort of change management, particularly operational change management, is difficult because you need to get the people on board. It's a mindset thing. So we need to understand, the way I would do that is you understand the as is process. You understand what the operators are doing at the moment and what the procedures and processes are telling them to do. Then you would look at, um, are are the operators following the procedures and processes? Because what you sometimes find is the operators don't always follow the procedure. They sometimes will have a better way of doing it, what you're trying to achieve. So they've developed a workaround or something which is sometimes more efficient and a better, more optimal way of doing it. So you need to sort of have that dialogue. It's all about dialogue engagement. So it goes back to the points I was making about asset management is about engaging, it's cultural, it's having that, positive intent. So when you're looking at, so some of the organizations I look at is rationalizing operational procedures. The operators will sometimes look at me and go, oh, you're trying to make me redundant. Because rather than having 10 operators, you might only need 8. whereas okay, that might be the case. I might only need 8, but the two other people may want, maybe in those positions, and they don't really like being in those positions. They may have opportunities to retrain and do something else. So it's an opportunity as well.
Right. Yeah. Great. I'll probably take this as a last question. There's a
Okay.
question from Narahari, and he's asking, "What about interoper?" I think this is a very common question. A lot of people have in their minds when we
Mhm.
talk about digital twins. He's asking, "What about interoperability issues between the operations technology and the information technology in the digital twin?" So, for example, you mentioned about the hydraulic model itself is a part of the digital twin, it is representing that particular component of the twin itself. So, how do we sort of make sure that there are no interoperability issues between the two models?
Yeah, I mean that is one of the issues that is generally faced when you're building a digital twin. That's a very good point, actually, because what you have to do, one of the first stages is make sure is look at compatibility issues. So you're looking at your operational IT, you're looking at your corporate IT, and sometimes in some situations the two don't talk to one another particularly well. So you need some integration software before you can actually start building the digital twin. But yeah, it's a very common issue, and sometimes puts people off, because they feel that they've got to invest. They've got this data and they've got this data, but they've got to invest to make it a combination.
Yeah, absolutely. So I think probably with that we will end the session. I sincerely thank you, Ian, to be able to present such a wonderful presentation. I think we all have enjoyed it a lot. Everybody has learned a lot from your session today. So thanks a lot for doing this.
Okay.
We had a fantastic audience, which was very participative, I think, and everybody has again. I'm very sure we are all going back to our homes, becoming smarter and better, understanding asset management. So hopefully, we'll see and have a repeat audience for the next session, which is in continuation to whatever Ian has presented today. And we'll probably be looking at some digital twin related aspects much more in details when
Mm.
Chris makes his presentation next time. So thanks a lot, everybody. I hope all have a good evening or a good afternoon, depending upon wherever you are, and see you again pretty soon. Thank you, guys.
Okay. Thank you. Goodbye.